All right. 4.1, interpreting derivatives in context. Now, remember, slope between 2 points, otherwise known as delta y over delta x, or the change in the dependent, okay, over the change in the independent. Okay, otherwise known as f of x over x. Units for derivatives would be whatever units for f of x, and then units for x. All right. Now, this next part, okay, is very simple, but also very, very important with what we're going to be doing over the next unit. Okay? If your derivative is greater than 0, that means your original function is increasing. Now, why does that just make sense? You have to remember, what is a derivative actually finding? Slope. And if slope is positive, that means you are increasing. And slope is positive, the function's increasing. Okay? Now, that means when the derivative is negative or less than 0, the function is decreasing. So we should be able to see a graph of a function and be able to look at this and say, well, I know where the derivative should be positive and where the derivative should be negative. I also know where the derivative should be equal 0 because those are the turning points. Okay. Now, putting things in context. Mr. Sullivan wants Mr. Brust to finish creating his packets in Algebra 2. The number of packets Mr. Brust has completed is modeled by P of W, where W is measured in weeks. Interpret P of 10 equals 1. Right? So what that means is this again is weeks, and this would be number of completed packets. So after 10 weeks, Mr. Brust has completed 1 packet. So you're really slow. Again, if you are given a function and just said, well, this value at this x gives you this, that's just a straight plug and chug. What we get after this amount of time. All right, but if we're asking to interpret the derivative, okay, now the derivative should be in terms of a rate. So we need to have a rate here. And it is very important you actually use the word rate in this. All right, so first, that is still the number of weeks. So on the 39th week, Mr. Brust is completing packets at a rate of 4 what? What is the rate? Packets per week. So again, the things we need to see, rate of, correct numbers, okay? There we go. It's almost done. The rate of Mr. Kelly is buying baseball cards per year is modeled by this function. So interpret B of 3 equals 150. That one should be very straightforward. So T is measured in years. So on year 3, Mr. Kelly has purchased 150 baseball cards. Oh, wait, nope, 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 nope. Sorry, erase that. I did not read the question. What is this function representing? What's the very second word of this sentence? The rate. This function is a rate function. So, it's saying during year 3, Mr. Kelly is buying. I'm just going to say buying because purchasing is too much of a word. Oh, I cannot write today. Why do you keep doing that? U, then Y. There we go. Baseball cards. At a rate. Again, if this is a rate function, you need to have that at a rate of 150 cards per year. If we take the derivative of this, okay, it says on the 4th year, the rate, so again, this is a rate function of, well, the rate Mr. Kelly is buying cards. Oh. Right, is increasing because it's a positive value at a rate of 10 cards. Now, you could write this one of two ways. You can either say per year, or you can say 10 cards per year squared. But in this case, increasing rate, again, you have to have rate here as well. And again, either one of these two. That's all the time we have. We will try to catch up as we progress through this week.
Do I just hit the sheet?
And we will ask too.
Okay.
And this time limit